Welcome to this lesson. In this lesson, we're going to talk about cotangent. Cotangent function, of course, we know how it's been defined. So let's recap on all of these concepts we've been talking about, right? Repetitively. First of all, we talk about function, right? We know cotangent is one of those rules. So cotangent is a rule that assigns each input, which is an angle in the domain, which is to be determined exactly one output in the range. And the stage set, of course, the three pillars of trigonometry still. Okay, so all the inputs to 6 trig functions are measured from standard position, including cotangent function and angle measurement, right? Counterclockwise, that's positive angle. Clockwise, those give us negative angle. Reference angle, the positive acute angle between the terminal and the x-axis. And definition provided that we choose any point on the terminal side of the angle, other than the origin. Okay, we choose a point, x comma y. So r is the square root of x squared plus y squared, which guarantees that this r is going to be positive. Now, the input for a cotangent function is angle. It produces a ratio, and this ratio is going to be x over y. Okay, x over y. So that's the cotangent ratio. Okay, domain. Let's see how we're going to determine the domain, right? The domain for cotangent, of course, we can look at the unit circle, right? And we talk about, we just need to use unit circle, and we get all the ratios we need, right? We get all the ratios for all 6 functions we need. Now, when we look at the ratio in terms of x over y, right? X are the red numbers and the y's are the blue numbers. For special terminals or non-special terminals, right? We just take the red number divided by the blue number. We just take the red number divided by the blue number. Along the way, okay, provided that assuming we don't know the domain and range yet, right? So we're going to look at this situation and to see what kind of number do we expect. You can see the special terminals could help us to see what is to be expected. What is to be expected for special terminals. So here I'm going to just have a couple rows and some columns, right? And we're going to observe. So we're going to take the red number divided by the blue number. Okay, so the angle are going to be the special angle, right? The first one will be 0, 0, right? When the angle is 0, 0 should be placed here, right? And the next special angle, of course, is pi over 6, right? We're pretty familiar with these drills. So we're going to do quadrant by quadrant. So in quadrant 1, a pi over 6, right? And the next one is pi over 4 and pi over 3, pi over 3. And of course, the next one would be pi over 2, right? So we measure the angle counterclockwise from the standard position, right? We get 0 here, pi over 6, right? From standard position to pi over 4, from standard position to pi over 3, from standard position, pi over 2, right? So we look at the first quadrant and, and the beginning in front and the 0, pi over 2. So let's look at the cotangent ratio. Okay, cotangent ratio. Okay, when the angle is 0, when the angle is 0, cotangent 0. So we're going to take the red number divided by 0. What do we get? Cotangent 0. We're doing 1 divided by 0. That's undefined, right? So this is where it's undefined. The question is just like in the case of tangent, when we approach 0 from smaller than 0, when we approach 0 from larger than 0, and that's going to make a difference, right? So we're going to leave this case a question mark, and we're going to continue. We're going to continue. Okay, we're going to come back. Okay, we're going to come back. Now, pi over 6. So we look at a cotangent pi over 6. And we're going to take the blue number, take the red number divided by the blue number. The red number divided by the blue number, that's going to be square root of 3. Okay, cotangent pi over 4. And that's red and blue is the same, so that's equals to 1. Cotangent pi over 3, right? And that's going to be half divided by root 3 over 2. That's going to give us root 3 over 3. Okay, how about cotangent pi over 2? Pi over 2. Cotangent pi over 2, that's the red number is 0. Blue number is 1. 0 divided by 1, that's going to be 0. Okay, so now we finished the first quadrant, okay? And now we have a question here, right? We have a question here. So what if we approach 0 from larger than 0, from smaller than 0? It makes a big difference. It makes a big difference, right? So we still leave this question here, okay? And next, we're gonna look at the second quadrant. We're gonna look at the second quadrant. Okay, we're going to look at the second quadrant. For the second quadrant, I'm just going to copy and paste, okay, to make it faster, right? So this one is going to be, we're going to have to redo all of these, of course, right? But this is going to start with 2 pi over 3, 2 pi over 3, right? 3 pi over 4, 5 pi over 6. And then pi, right? Pi. So what happened is that certainly we don't have 0 anymore, right? We don't have 0 anymore. So 2 pi over 3. So we measure the angle from the standard position counterclockwise, we get 2 pi over 3, right? That's 2 pi over 3. And then we, from standard position, we measure 3 pi over 4. From standard position, we measure 5 pi over 6. From standard position, we measure up to pi, right? So these are the cotangent value we're going to take a look. Okay, so what do we get? Well, all we have to do is we know that cotangent 2 pi over 3 is going to be equals to the red divided by the blue. The red is negative, the blue is positive, and this is going to give us a negative root 3 over 3. Cotangent 3 pi over 4, and that's still red divided by blue, but they're opposite to each other, so it's going to be negative 1. Cotangent of 5 pi over 6, okay, that's red divided by blue, that's going to be negative root 3. And cotangent pi, what happened at cotangent pi? We're taking red number negative 1 divided by 0. So once again, we have an undefined. So we have two undefined cases. What are we going to do? What are we going to do before we move forward? Right, before we move forward. Okay, before we move forward. Obviously, 0 cannot be in the domain, pi cannot be in the domain, right? So we're going to continue into the third quadrant and fourth quadrant, right? To see how many terminal that will cause undefined situation for cotangent. Okay, so let's keep going. Quadrant 3. Okay, we're going to plot points just a little later. We're going to plot point just a little later. Now, quadrant 3. Quadrant 3, and of course, all of these points will change, and all of these will change, right? So we're going to measure the angles from the standard position, right? 7 pi over 6 from standard position, 5 pi over 4 from standard position, 4 pi over 3, and 3 pi over 2. Okay, so these are the 4 values we're going to evaluate. All right, so here we're going to have 7 pi over 6. Right? And the next one will be 5 pi over 4. And the next one is 4 pi over 3. And the next one is 3 pi over 2. Okay, and the red number divided by blue number. Red number and blue number are both negative for these 3. So negative divided by negative is going to be positive. So cotangent 7 pi over 6 is going to equal to root 3, square root of 3. And cotangent 5 pi over 6, 5 pi over 4 is going to be equals to positive 1, because negative red square root 2 over 2 divided by negative root 2 over 2, that's going to be equals to positive 1. So cotangent 4 pi over 3, 4 pi over 3, you can see what do we get by just apply definition, right? So we're going to get a square root of 3 over 3. And for cotangent 3 pi over 4, I'm sorry, 3 pi over 2, we have 0 divided by negative 1, and that's going to give us 0. Okay, that's going to give us a 0. Quadrant 3 is being taken care of. So let's look at a quadrant 4, the last quadrant. Okay, quadrant 4. And of course, we're going to get rid of all of these. We're going to get rid of all of that, right? So, and we're measuring the angles from standard position. Counterclockwise, we get to 5 pi over 3, right? From standard position, 7 pi over 4. From standard position, 11 pi over 6. 11 pi over 6, right? So we're gonna, and then finally 2 pi, right? So from standard position, go around 1 cycle, 2 pi, right? So we get all these 4 inputs, and these are 5 pi over 3, 7 pi over 4, and 11 pi over 6. 11 pi over 6. And lastly, 2 pi. Okay, so let's look at the cotangent values. Cotangent of 5 pi over 3, red number divided by the blue, right? We're getting negative root 3 over 3. Okay, the red number divided by the blue number, they are opposite in sign, different in values, but these are familiar values. If you guys have any questions reading this piece, feel free to ask me, or you just pause and do your calculation, okay? So cotangent 7 pi over 4 Okay, 7 pi over 4, that's equals to -1, right? Because the red is √2 over 2, the blue is negative √2 over 2. These two divide, we get -1. Cotangent 11 pi over 6. And that's going to be the red divided by blue. So we're going to end up with -√3. Okay. And the cotangent 2 pi. So we get to do 1 divided by 0 again. So this is time, it's undefined again. Undefined again, right? So we have done the 4 quadrant, and we can certainly do the clockwise. Okay, we can do the clockwise from quadrant 4, quadrant 3, quadrant 2, quadrant 1, right? We can go that way. Okay, so let's first look at just these values, right? From 0 to 2 pi in this interval. And we got some points, right? We got some points from the first quadrant. From the first quadrant, we get these points, right? So we're gonna make the graph. Okay, we're gonna make the graph. Let's plot the points. So y equals to 0. I'm gonna get the rectangular system started, right? We don't, wait. We don't need that anymore. So I'm just going to make some adjustment from 0 to 2 pi. So that's going to be approximately, okay? And the y direction, maybe I can make it -5, 5, right? With the ratio being calculated, right? We have input, output, right? So this corresponds to a point. This point is pi over 6 and √3. Pi over 6, √3. And this point is going to be pi over 4, 1. And that point is going to be pi over 3, comma, √3 over 3. Okay, we're gonna plot these 4 points. Okay, so pi over 2, comma 0. Okay, so we're gonna plot these points. Once again, pi over 6 is going to be the arc length of on the unit circle facing that angle. Okay, so it's still the same, really the same idea as all the other pictures. And now what we got here is that we're going to plot all these points in place. And I'm going to choose a color, right? So let's see, what color are we going to use? Let's see, what color shall we use? Maybe this light blue, or let's use this light blue. Okay, a point, right? So it's right there, right? It's right there. So this point is marked, okay, as pi over 6 and √3. And what is the meaning? The meaning, once again, is the same. Pi over 6 is the horizontal from the origin, right here, pi over 6. Okay. And the √3, we're going to use that light blue right here. That's √3. And this gold piece, okay, this gold piece is still this arc length, same. Okay, and the light blue color is the cotangent ratio. Okay, you can see it's consistent with our other pictures. Okay, consistent with our other pictures. So we continue to plot, right? And the next point would be pi over 4. So you guys go ahead to do it. Okay, so pi over 4, comma 1, right? And the next one, pi over 3, root 3 over 3, and pi over 2, 0. There we go. We got these pictures. We got these points. We got these points. That's from the first quadrant. Okay. And of course, it would go up, right? It looks like there's a pattern. This is going to go up. Okay. But that's going to be what happens if we approach 0 from larger than 0, right? In other words, if we measure the angle, right? If we measure the angle, we know that at 0 it's undefined, right? If we measure a close to 0, as close as possible, what will happen to the cotangent ratio, right? And in other words, if the arc length is approaching 0 from larger than 0, what's going to happen? It looks like this curve is going to go, as we're getting closer and closer to 0, is going to go higher and higher and higher, right? It doesn't touch this, because it cannot be 0. It's undefined as 0, but it can maybe get as close as possible. So that's how we see the pattern, right? Okay. So now let's take some examples. Right? Close to 0, right? Close to 0. So let's look at using our calculator, right? Using our calculator to calculate something like, say, 0.1, right? Cotangent 0.1. 0.1 is larger than 0, right? Cotangent 0.1. What does cotangent 0.1 equal to? Right? What does it equal to? So I'm going to put it right here. Make this just smaller. Right? What is a cotangent 0.1? Cotangent 0.1, plugging your calculator is pretty big, right? It's larger than all of these values. Then we say, how about cotangent? So let me insert a column, right? And insert a couple more columns. What about 0.01 cotangent, right? So that output is 9 point. So this is going to be 9 point. Wait, this guy. I put this number in here, right? How about cotangent 0.01, right? 0.01. What would that be? Even higher, 99.997, right? So you can see the tendency, right? You can see the tendency. Let's do one more, 0.001. What do we get? Cotangent 0. This is, I'm using radians, okay? 0.001. What do we get? We're gonna get an even larger number, 1,000. My God. 1,000, right? What does this tell us? Wait, what am I doing? I think I delete something by accident. Okay. I deleted something by 0.001, right? Cotangent 0.001, that's going to give us even larger number, right? So what will be our educated guess? Okay, it's under, below. So as we're getting closer and closer to 0, from larger than 0, the ratio is going, the cotangent ratio is going to get higher and higher and higher. Doesn't touch the y-axis, but get as high as possible, right? So that's what we see. That's what we see. So from these points, we kind of guess this curve from this side is going to go higher and higher, right? And from left to right, it's going high, coming down this way. Okay, so let's look at the second quadrant. Let's look at the second quadrant. So we have an estimate, right? So on the second quadrant, we have these points. We have these points, 2 pi over 3, comma, and the ratio of negative √3 over 3. The second point is going to be 3 pi over 4, right? Input, output. Input is the arc length, and the output is the cotangent ratio. And the next one, we got input is 5 pi over 6. And the output is negative √3. Negative √3. Okay. I'm trying to tell myself, is it fast or slow? Please give me feedback on that, right? So we have all these 3 numbers. So we're going to put them in the graph. Okay, we're going to put them in the graph. Okay, we're going to put them in the graph at a point, right? Another one, 3 pi over 4. And this is going to be -1. Next one. This is going to be 5 pi over 6. And that's going to be √3. There. Right, you can see the point going down this way. So then we're getting closer and closer to pi. And we know that at pi, it's undefined, right? It's undefined. So how about we get closer and closer to pi from smaller than pi, right? So this is a pi. This point is pi. Okay, somewhere here. Okay. So what do we see here? Okay, I think it's going to go down, 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 right? That's going to go down, 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 down. So how do we try that? How do we see it for ourselves? Okay, what we can do is that we can put these points over here, right? We know it's undefined as at pi, but we're gonna choose values that are closer to pi but smaller than pi, right? Because we're approaching pi from smaller than pi. So we're gonna put a couple numbers, right? Say, wait, not this one, not a row, column. Okay, sorry about that. I'm gonna choose some columns and 2 columns, 3 columns. So here, right? So I'm gonna choose a value which is pi minus something, right? Pi minus something. Pi minus a small number. So that's closer to pi, right? So say pi minus 0.1, pi minus 0.01, pi minus 0.001, right? We're gonna see the cotangent value. And the cotangent of pi minus 0.1. What do we get for that value? Let's see if it calculates for me. It doesn't. I have to do it separately. Okay, so this number is going to be negative 9.966, right? So how How about for pi minus 0.01? That's even closer to pi. And that value is going to be negative 99, right? Negative 99, so it's even smaller. And the next one, and of course, you can anticipate this is going to be even smaller. So this value numerically is negative 1,000. Okay, negative 1,000. What does this tell us? So as our angles approaches pi, right? It's undefined at pi, right? But if we approaches pi from smaller than pi, and cotangent of that angle is going to approach negative infinity. So sure enough, right? So we can anticipate the curve is going to go this way, right? So let's confirm that, okay? Cotangent curve, and there. Okay, and it periodically, okay? So now we can tell that 0 is a vertical asymptote, pi is a vertical asymptote, right? So let's put those asymptotes in place. Okay, so there we go, this right, this one, vertical asymptote, that's a broken line. I'm going to choose what value, what, maybe pink, right? And of course, we have another vertical asymptote. We have many vertical asymptotes, we do, okay? Because the period you can see is pi, every pi, right? So these are the vertical asymptotes. So 0 is undefined, pi is undefined, and 2 pi is undefined. On the other direction, negative pi is undefined, and so on and so forth. Okay, we're not going to do so many points, but just look at the phenomena we just observed, right? Just look at the phenomena we have just observed. So I'm going to take this picture and put it up there. Okay, put it up there. Wait, what's going on here? Wait, what is going on? Okay, copy and paste right there. We just did these values, didn't we? Okay, closer to 0, closer to 0. When the angle is approaching 0, right? You see these numbers approaching 0 from larger than 0. Okay, so the angles are approaching 0 from larger than 0. And the cotangent ratio is going to go higher and higher to positive infinity. So now we can conclude, right? It's undefined as 0, but okay, as the angle approaches, so I'm going to insert a row, okay, to express that phenomena. Okay, as the angle approaches 0 from larger than 0, right? This is from larger than 0. Cotangent of that angle is going to approach positive infinity. Okay, and how about the other one? You guessed it. I think you guys can guess it, right? So in the other direction, right, what we just did, right, what we just did is show to us, okay, as we're approaching pi, closer to pi, okay, as we're approaching pi from smaller than pi, okay, cotangent is approaching negative infinity, okay? So let's write it down. So as the angle approaches pi from smaller than pi, cotangent of the angle is going to approach negative infinity. Very, very useful stuff for your future calculus classes. Okay, and it follows a similar pattern. This piece you can see approaches pi from larger than pi, and then approaches in positive infinity, approaches 2 pi, from smaller than 2 pi approaches negative infinity, right? So it just goes on and on and on. Okay, now, so that's the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, we're not doing the we're not plotting the points for third and fourth quadrant, and I leave that for you, right? It's going to be another process, similar. It's going to be repetitive. On the other side, cotangent, right? Cotangent is going to be, what if on the negative side, right? So let's look at the negative side. So we're going to see the negative side. Same thing, right? Periodic. Okay, so this vertical asymptote is actually negative pi. X equals to negative pi. Okay, so I'm going to draw another vertical asymptote. And I certainly can draw more, right? So these are the vertical asymptotes. So what are these points, right? What are these points, if we still remember, right? So let's mark these points, right? Let's mark these points. And this point is too thick. Okay, so I'm going to write it thinner. Okay, this point is the gold color, right? The arc length, right? Which is pi over 6. And the output ratio, cotangent output ratio is √3. And that point, pi over 4, comma 1. And the next point here, that's going to be pi over 3, √3 over 3. √3 over 3. Okay, forgive me my writing. This is a pi over 2, 0, right? So this point is pi over 2, comma 0. Okay, and this point is a negative pi over I'm sorry, it's 2 pi over 3, negative √3 over 3. And this point is 3 pi over 4, negative 1. And this point is 5 pi over 6, negative √3. Okay. All right. So with that said and done, we got the picture. And some of the points, right? So this is first quadrant, second quadrant, third quadrant, fourth quadrant, third quadrant, and this is the second quadrant, first quadrant. Okay. And how about the vertical asymptotes, right? The vertical asymptotes, if I mark this one, is going to be x equals to pi. Okay. input cannot be pi. And this vertical asymptote is x equals 0. That's a y-axis. And this one is x equals to negative pi. So now we should have some ideas about the domain, right? The domain of cotangent. Domain of cotangent, right? So for cotangent, domain, it can be any real number, but the angle cannot be what? The angle cannot be 0, cannot be pi, cannot be 2 pi, cannot be 3 pi, and so on and so forth, right? So what is the common pattern? Actually, plus minus cannot be plus minus multiples of pi, okay? So the common feature of writing this is domain. So A cannot be any multiples of pi, where k is any integer. How about range? Range is pretty obvious. You can see we can go as high as possible, as low as possible. So range is from negative infinity to positive infinity. And there we go. That's a cotangent domain, range, and graph. Domain, range, and graph. Okay. Feel free to do your version of it, plotting the points. And in this, at this piece, we're just going to we skip those other intervals. Okay, I'm gonna skip these other intervals. Okay. So that's cotangent curve and the cotangent domain and range. And that's all for this lesson. Thank you for watching. See you next time.